And we're going to follow the same process we did with lines. If you had the graph of a parabola, and you tried to do 1 over that parabola, is there a non-permissible value? Yes. It happens at the x-intercept. So at the x-intercept, we're going to draw a vertical asymptote, just like we did with lines. With lines, we had a horizontal asymptote at y equals 0. Will we have one with this one? Well, I kind of gave it away when I said every graph in grade 11 that you do will have a horizontal asymptote at y equals 0. So yes, I kind of gave it away that this one does, because the graph, this red graph goes up forever. That means your y values are going to get huge. If you do 1 over a huge number, you are going to get close to 0. Are there any points on this parabola that you know? Yes, you know this point right here. It happens to be at 3, 4. Where is that point going to be on our reciprocal graph, which I'm going to do in blue? It's going to be at 3, 1 over 4. I also have this point at 2, 1. When I do the reciprocal, I get 2, 1 over 1. Ooh, you guys are getting better, right? I'd also have at negative 1, 1. I would now have negative 1, 1 over 1. And with this, do you see that just like before, we have an asymptote, we have this as section 1, and we have this as section 2. Do we have a point in section 1? We do. That's enough to draw this half towards its asymptotes. We drew 2 points in section 2. That means we have enough to draw this. And for each of the possible graphs that you can get with quadratic equations, you've come up with special names to describe them. This graph is called the volcano. Can you see like that? Like the asymptote is red. It's like spewing lava out of the top. It's like, this is the volcano graph. It is not an official mathematical term.
What if the volcano graph was upside down?
That's what we're getting to. We're going to name them all. Here we go. On the next page, shape number. Well, let's start with the volcano. We'll start with shape number 2. Okay, we're going to add the asymptote and add this asymptote in there, and we're going to name this one the volcano. Add the asymptote on this one. Add the asymptote there. All right, I'm always up for new names, but I do have a name for this. But I'm willing to hear. I'm not going to influence you by telling you my name first. What do you think?
I mean, obviously, to have the same starting letter as volcano, a valley.
Valley's not bad. I don't mind valleys. Okay. It's not the one I came up with. A waterfall.
Perhaps a sinkhole.
Sinkhole. Sinkhole's not bad. I call this one the hole. Call this one the trench. Because there's like in the ocean, there's like really deep trenches.
Like in Mariana.
Yes. That's like the deepest trench. Okay. Shape number 1. Okay.
It's a lump.
Not the lump. Close. Oh, it's close. Very close with bump. Speed bump graph. Yes, there it is. This one. Speed bump graph. And the next one is the patron graph of Winnipeg. The pothole graph. There it is.
Oh, I know that.
Does pothole have a space or does it not have a space? Is it one word?
Pothole? Just, I think it's just a hyphen. Yeah,
I don't think it has a hyphen.
I'm pretty sure like Speed Bump House Bomb has a hyphen. No.
No space? Pothole? I think it's no space.
Pothole.
Pothole. Pothole. That's what it is. Okay, good. And shape number 3.
From those, from the asymptote, of course. 2.
Okay. I don't think you'll ever guess my name for these ones.
Picture of fire in the hole.
Oh, it's close. I call this one the sad face.
Sad face.
Oh.
Oh no, I feel so bad for her.
And the last one.
Batman.
It is the Batman graph.
Oh my god, it is Batman.
It is the Batman graph. That's so awesome. That would be such a good multiple choice question, right? If you graph blah blah blah, you will get a pothole, a trench, a volcano, or Batman. And anybody who would look at my tests from another class would be like, what is going on?
But see, now that that's the Batman, clearly they're both the Batman, because Batman's just upside down as a bat.
Oh, see that, but that's not. You have to be like, you have to see the front. That's sad. So it couldn't end with the sad face. We had to do Batman last. All right. Okay, so this will make one of those graphs. What we have to do is first graph what's on the bottom. So first, we are going to graph y equals negative x squared minus 1. This is a parabola. Can you tell that this parabola, well, all parabolas have, I was going to say, can you tell it has a vertex? Well, yes, because all parabolas have a vertex. Can you tell where that vertex is? That vertex is going to be at 0, -1. And because the a value is negative, this parabola is going down. Has an a value of -1, so we could do the go over 1, down 1, over 1, down 3. Or you could actually just plug in values, right? Like when x is 2, how hard is it to figure out that 2 squared is 4 times a negative is -4 minus 1 is -5? It's not hard to label the points from the equation either. Then we go to our graph. And first of all, we would say, does it have any x-intercepts? Does it have any non-permissible values? But we can see from the graph it doesn't have any x-intercepts. Can you see from the equation that it doesn't have any non-permissible values? Okay, so sometimes being able to analyze equations is really helpful, especially in higher level math. Like x squared always makes a positive number. Times by the negative will always make it negative. Or 0, right? It's possible it could be 0. It's either this first part part either going to be 0 or a negative number. And then you subtract 1. You for sure will always have a negative number. And it can never equal 0 as a result. So there's going to be no vertical asymptotes. We will have a horizontal asymptote at y equals 0. You can either use the strategy of the fact that I told you every graph is going to have that for us. That's a good strategy to use. Or the fact that it goes down forever, so it will have extreme big negative y values. And if you do 1 over an extremely big negative y value, like 1 over negative a million, it'll get really close to 0, but not equal to 0. Now, some points. Hey, by the way, you only have one section. But you might need to do a few more points before you can figure out what this graph is going to look like. Like I have 2 comma negative 5. I'm going to graph this one in green. Would it make sense that I would have 2 comma 1 over negative 5? The vertex seems like a very important point. My vertex is at 0, negative 1. And I would get 0 comma 1 over negative 1. Ooh. Which stays the same. Something with reciprocals. Can you see that this is the biggest value on the blue graph, a maximum? It's going to become a minimum on my green graph. In fact, if I also do a point over here, let's say I do this point, negative 1 comma negative 2, I'm going to get negative 1 comma 1 over negative 2. And how fitting it is that we start off, like I said, with the patron graph of Winnipeg. We have the poplar. Oh, man. Okay, the questions to go with this. 3, 6, and 11. Oh.